All right, 8th grade math, test 18 study guide, problem number 1. So number 1 says decide which expressions below are equivalent to this. So what we have to do is take the very first expression they give us and go inside the parentheses. And inside the parentheses, you're going to copy the base and add the exponent. So remember, there's a 1 there. So 2 plus 1 is 3. So inside the parentheses, I have 2 to the third. Now, the way I do power of power, little exponents next to each other, that's the shortcut there is not to add. The shortcut there is to multiply. So I copy the base and I go 2 times 3 is 2 to the 6. We have to check which of those expressions are the same as that. Expression 1 was just like we did inside the parentheses. We copy the base and add the exponents. Well, 2 to the third is not the same as 2 to the 6. Expression 2, that's where we're dividing powers with the same base, and we learned in class the shortcut for that is just to copy the base and subtract the exponents. Remember, you go top exponent minus the bottom. So 10 take away 4 is 6. That's 2 to the 6. That's the same, so expression 2 will be part of our answer. Expression 3, we have, it's a combination of expressions 1 and 2. So you're going to go up top and do that part first. You're going to add first. Remember, even here, we always do the adding part first. We're multiplying these powers with the same base, but the way we do that, the shortcut for multiplying, is to copy the base, copy the big number, and add the exponents, add the two little numbers. So I got 2 plus 3 is 5, 2 to the 5th. Now we're going to divide powers with the same base. I copy the base, copy the 2, and go 5, take away 2, or 2 to the third. I see that's not the same. And expression 4 is 64. So I have to go back to the original problem where it's 2 to the 6. 2 to the 6 means 2 times 2, basically 2 times itself, 6 times. And we memorized in class that 3 2s, 2 2 2 is 8. So I basically have 8 times 8, which is 64, which means that expressions 2 and 4 are the same as the expression given. So what we do is we simplify all those first and see which ones are the same. Now, for number 2, we need to say which whole number is closest to the square root of 1,000. So we remember in class we learned we have to narrow it down, right? So we start out 10 times 10 is 100. 20 times 20 is 400. And remember I taught you guys how to do that in your head real quick, right? So as we're narrowing it down, we see that this 1,000, the radicand 1,000, is in between the perfect square 900 and 1,600. So I know it's in between 30 and 40. Okay, so what I do then is I start to narrow it down. I ask myself, which one is it closer to? 1,000 is closer to 900 than 1,600, okay? So pretty close. So I'll start guessing and checking, right? I'll say pretty close is maybe it's closer to 30. Maybe I'll try 32. If I go 32 squared, I get 1,024. That's a little too big. And then I check this next one down, 31 squared. I get 961. I see that these two are consecutive. That means right next to each other, right? It goes 31 and then 32. And the square root of 1,000 is in between these two. So I'm trying to find which two perfect squares that the square root of 1,000 is in between. I figured that out, narrowed it down, multiplied, saw the 2, and then I ask myself, which one is it closer to? Is it closer to 961 or is it closer to 1024? And since it's closer to 1024, that means it's about 32. Not exactly, but it's closer to 32. The square root of 1,000, it's about 32. That's what it equals. Okay, so remember to narrow it down first to save yourself a lot of work on that. Problem number 3. We have to say how many times larger than 4 times 10 to the 12th is 8 times 10 to the 14th. And if they word it that way, then and then is, then you know the second number goes on top, or the bigger number goes on top. We know it's because of the exponent, not because of the coefficient, right? So I take the bigger number over the bottom number. I go 8 divided by 4 is 2, and 10 to the 4th divided by 10 to the 10 to the 14th divided by 10 to the 12th. Again, that's where we copy the base, subtract the exponent. 14 take away 12 is 2. So I have 2 times 10 to the second power. Number 4 says, find the value for the x that makes this true. In other words, we're going to solve this. So for number 4, find the value for n. I was looking at number 5 there. So we're going to solve this. We always distribute and combine like terms first. In other words, we simplify first. That's already, we don't have to distribute, so I'm going to do the rule for subtraction. So you see that subtraction? That's where I'm going to draw 2 sticks. I'm going to add the opposite, right? That way I can use teams. So I'm going to add my n's together. They're on the same team, so I add them. And I'm going to add my constants together, the one with no n's, right? And those are opposite teams. When they're on opposite teams, we subtract. And we ask ourselves who has more. There's more negatives than positives. So I simplify both sides. Now I'm going to isolate the variable. Now normally I get my variables on one side next, right? But there's no variables over here. There's no n's over here. So I add 3 to both sides. Again, I have negative 48, positive 3. Those are opposite teams, so I subtract. This time, again, there's more negatives than positives. And then I divide by the coefficient. Negative divided by positive is a negative. And my answer is negative 9. Okay, so number 5. Same idea. They say find x. We're going to solve this. This time they give us some parentheses, so we're going to have to distribute first. So remember, always distribute first, then combine like terms. Get your variables on one side, then isolate. Okay, so we're going to distribute first. We have subtraction there. We want to do the rule for subtraction. It just helps with our multiplication. Also makes it so we can use teams. I go 1/4 times 4x. Well, if it's 1 over 4, it's like dividing by 4, right? 4 divided by 4 is 1. 1x is just x. So 1/4 of 4x is x. Same thing with negative 8. What's negative 8 divided by 4? Negative 2. So I distributed. Now I'm going to combine like terms. So again, these are opposite teams, so I subtract. There are more positives this time than negatives. That's why it's positive 10. Subtract 10 from both sides. We're doing inverse operations. And this time there's more negatives than positives. That's why it's negative. And my answer is x to the negative 5th. Problem number 6 says, pick all the equations that have one solution. Well, you need to understand, for these problems here, we don't have to solve all of them. Instead, all we do is we simplify each one. Again, simplifying is distributing combined like terms. So we simplify each one, and then we can stop right there. Because once it's simplified, if you have different x's on both sides or different coefficients, there's going to be one answer. If you have the same, there's either infinitely many solutions or no solutions. Okay? So let's talk about that. Equation 1. Again, simplify first and then stop. You don't have to solve all of these. That's too much work. So I do my rule for subtraction. Look, I did add the opposite, right? Okay. Then I'm going to distribute the negative 1. That's what it means to have a minus sign outside parentheses. You distribute a negative 1. And I can stop. Both sides are simplified. Now look at your x's. You see the number in front? If those are different, or if there's an x over here and no x over on this side, like this problem over here, then there's automatically one answer. I can stop right there and say there's one answer. Or sometimes the directions say which of these is infinitely many or no solution. And I would know that I wouldn't choose this one because this has one answer. Okay, this is going to have an answer. My x's won't cancel out because I have different coefficients. Next, equation 2. Again, we're going to take this equation and do the rule for subtraction first. So I'm going to add the opposite. Okay, don't need to do it here. Subtraction, I do it there. I need to add the opposite here. Again, a negative sign outside parentheses means to distribute a negative 1. Inside here, since that's a subtraction problem, I do the rule for subtraction. Then I distribute. 8 times 2x is 16x. 8 times 1 is 8. Copy the rest that I'm not using. Negative 1 times 3 is negative 3. Negative 1 times negative x. Negative times negative is positive. That gives me positive x. So we distribute, combine like terms now. On this side, I add constants to constants. I do not add constants to x's. So a plus negative 4 is 4. There's no more positives than negative. Over here, add my two x's together, and I can stop. Both sides are simplified. Stop. Don't finish solving it. Look, I have the same coefficients. So either this is infinitely many solutions or no solution. Since these are different constants, this is no solution. If it was same, that would be infinitely many. So I would say this has no solution. So this isn't part of my answer because this time, for this problem, they're asking which one has one solution. We really have to be careful of the directions. We don't ever assume. So equation 3, again, directions say, we're paying attention to directions, how many have one solution? That's what I'm looking for. So again, we're going to do rule for subtraction and distribute and combine like terms. Okay, I add my two constants here to get 4, add my two x's to get positive 10x, and stop. Take a look at your coefficients. You see your coefficients? They're different. That means there will be one answer, for sure. Okay, when I move my x's to one side, they won't cancel out. Right? When they're the same, they're going to cancel out. That's why it becomes one of those special cases, infinitely many or no solutions. So this will have one solution. Now we test equation 4. Again, always pause the video if I'm going too fast. Play me in a slower speed. Okay, but for those of you that get this, I want to keep it shorter, so I'm speaking kind of quickly, right? So we go ahead and do the rule for subtraction. Distribute. Over here, we don't have to distribute, so I combine like terms. I add, there's 3 different x's. I have 2 positives and 1, and then 4 more negatives. In other words, I have a total of 5 negatives and 2 positives. Opposite teams means subtract. That's where the 3 comes from, right? The difference of 5 and 2 is 3. There are more negatives than positives. I still need to combine like terms over here. I see I have same. I don't keep solving. Once I'm simplified, I look. Same coefficients, same constants. That's the one that's infinitely many solutions. So the only ones that had one solution were equations 1 and 3. Looking at problem 7, they give us a linear function and they tell us to say which ordered pairs of solutions. So all I do is plug those ordered pairs in. Remember, this is x and this is y. So y goes where the y goes. Put the 18 where the y goes. Don't put the negative 2 first just because it's first. Put the negative 2, since it's x, where the x goes. Remember to multiply first. Negative times negative is positive. And since 18 equals 18, that makes this true. If it makes it true, it's a solution. Another way to say that is it's on the graph of the line of that equation. Now we test 2 again. Plug in y where the y goes, y where the y goes, x where the x goes. Multiply first. That's true. So points 1 and 2 are part of our answer. Now we go to point 3. Plug it in. Multiply first. Use your teams. Negatives have more. These are not true. This is not true. This is not on the line. This is not a solution. And when we test 4, we multiply first. That doesn't work either. So our answer is only 1 and 2 are solutions for that equation. So number 8, we're going to find the slope from the graph from number 8. You could always do it the way I taught you in class, the way that works for word problems, tables, and everything, even this problem. However, if they give you a graph, I really want you to take a shortcut. Because look, if we have to find the slope for this and the slope for all these over here, so we can compare to see which of these relationships down here are the same as the graph, the same slope, I'm going to do the shortcut when they give me the graph. So I'm going to take 2 points on the lattices, right? There's a point right here, and there's a point right here on a lattice. So I can see it's a negative slope. I go down 1, 2, 3. Down 3 means negative 3 over, and then I go to the right 1, 2. So my slope is negative 3 over 2 for the graph. Okay. Another way to think about it is negative 1/2, but we really want to keep slope not as a mixed number, but as a fraction. Okay, even if it's an improper fraction. So relation 1 is a table. So I could take 2 points and subtract them. However, I see if they give me 0, 0, I know it's proportional, so I could take a shortcut. I can just take 1 point and put y over x. Put y over x, I get a slope of negative 1. That's not the same as the graph. Again, we're not trying to find which of these is the exact same as the graph. We're trying to find which of these has the same slope as the graph. So sometimes people get confused and don't read the directions. So relation 2, this time they give me a table. They don't give me a 0, 0, so I don't know if it's proportional. So I take 2 points, and this is what we learned a long time ago and did it many, many, many days in class. We go y minus y over x minus x, and I get the same slope. Okay, pause the video if you need to, but do the work. Make sure you get what I get. Relation 3 is an equation that's already in slope-intercept form. You see that? The slope's whatever in front of x. Negative 3 over 2 is in front of x, so they give us a slope for that one. That's the same as the graph they gave us. In relation 4, they only give us 2 points, so again, we go y minus y over x minus x. Okay? So I do the rule for subtraction in teams. I get negative 64 over negative 8, which is a slope of 8. That's not the same. So the only two that are the same are relations 2 and 3. So for number 9, we have to write the equation. So if I look at the graph, the two things we memorize this, right? I made you say it many times in class. The way we write an equation, the two things we need is a slope and y-intercept. Well, you can see the y-intercept. It's right there. It's at negative 1. It's just where the line hits the y-axis. So it's y equals mx plus b, right? Or y equals mx plus negative 1. Now, to get the slope again, when they give me a graph, I take 2 points on the lattices. I rise up 1, and run 1 left. So I know it's a positive slope. So I have a slope of 1 and a y-intercept of negative 1. I put that in y equals m. The m goes here, right? mx plus b. And then I simplify. 1x is x, plus negative 1 is minus 1. So for number 10, they give us a system. And they tell us to, let's see, the directions say, select a statement that correctly describes. Oh, we got to describe the solution to it, so we got to solve it first. So I'm looking at both of these, and neither of these have a variable isolated. So I'll pick the one letter that has no number in front, no coefficient. And I'll isolate that letter. I'll move the negative 3x by adding 3x, and another way to say this equation is y equals 3x plus 4. Now, I have to substitute this equation into the other one where the y goes. So I rewrite that top equation, 24x plus 3 times y. Now remember, y is all this, so I put all this instead of y in parentheses, and then I copy the rest. So I've intersected these two now algebraically, and I go ahead and distribute. 3 times 3x is 9x, 3 times 4 is 12. Combine like terms. Now I isolate the variable. I work farthest away from the variable first, doing inverse operations, and I see that x is 1. Now, I can stop right there, because when they want me to describe the solution and they give me 4 choices, I know that it's not infinitely many. It's because it's not one of those weird situations where I get the same coefficient on both sides, right? My variables do not cancel out. So it can't be A or B. It has to be C or D. I mean, there is one answer, right? And I know my x is 1, so I don't need to pick C. So I can stop right there. My answer has to be D. The solution is 1, 7. So for number 11, we're solving a system again. This time they gave me the 2 equations in slope-intercept form. I just do what I did last time. But I say thank you for doing the first step for me. You already isolated a y. I'll substitute that in there. So I know these look confusing, but all you do is you say this equals this. Okay, we don't even have to distribute for this. We get our variables on one side. So after I do my rule for subtraction, I can either subtract 2x from both sides to get rid of my x and move it to this side, or add 3x to get rid of negative 3x and move it to this side. I like to avoid negatives just because of inequalities in high school later on. But combine my like terms here. 2x and 3x is 5x. Got my x's on one side. Now I'm ready to isolate the variable. So I work farthest away from the variable first. I do the negative 2 first. The opposite of negative 2 is to add 2 to both sides. That gives me 5x equals 25. Divide by the coefficient, and x equals 5. Now, for this problem, number 11, they said find the x value. So I already found the x value. It's 5. I can stop right there. I don't need to find the other one because of the directions. Now, if it would have been easier to get the x first, the y first, I'd plug it back in and get the y if they asked for x. But since they asked me for x and I already found x, I can stop. Number 12. It's that they give you one equation, and they tell you which of these 4 down here will create an infinitely many solution with this one. And they're basically asking you which one's the same equation. So I'm going to show you the quickest way to do this, right? The quickest way is if you look at x's and you say I multiply whatever I multiply this by to get this x. If I multiply the others by the same thing, it's the same equation. In other words, these two will be infinitely many solutions as a system. So for 2x, I add 2 to get 4x. For negative y, I multiply. For negative y, I multiply by 2 also. And for 10, I multiply 2 to get 20. So this is the one that's going to make infinitely many solutions with that. Second one, the x's didn't change. The y's didn't change. Looks good so far, except the 10's changed. So I multiply the 10 by a negative 1. I didn't multiply the others by a negative 1. It has to be the same factor for all 3 terms in order to be infinitely many solutions. For c, the x's I multiplied by 2. The y's I multiplied by 2. The 10 I did not multiply by 2, so c will not make infinitely many solutions with the given equation. And for d, x's didn't change. Y was multiplied by negative 1, so my answer is only A. So for number 13, they talk about 2 gyms and charging, and they ask when will they be the same, right? So for the first one, they say gym A charges $25 per month. Per month, that's your hint that the x is going to go there, and x is going to be the number of months, right? And then they say $45 initiation fee. That's a one-time deal. One-time deal we learned in class, that's our B. So this is y equals mx plus b. Y is always money. Money is always y, right? Okay, so the money is 25 times each month plus $45 just to sign up. Gym B, there's no sign-up fee. It's just $30 a month. $30 per month means 30x. When they're the same, I set them equal to each other. In other words, I'm solving the system. My y is isolated. I substitute this where the y goes. And there's no need to distribute. I get my variables on the same side. And isolate the variable, and I get x equals 9. My answer is 9 months. For 14, it says, the following are examples of relations which are functions. Now, I want you to understand, relation 1, they have that absolute value of y equals x. Anytime you see absolute value of y or y squared, that's not a function. Every other equation just considered a function. Okay, so the first one can't be a function. Number 2, we're looking at the x's, right? It's all about the x's. If the x's repeat, which they do, it's not a function. Okay. Number 3, let's take a look at the table for number 3. So for number 3, they give us a table, right? And I look at my x's. None of my x's repeat, so it's a function. If the x's don't repeat, it's a function. Okay. And number 4 is a graph. Number 4, remember that vertical line test. I'm going to draw a straight line through any points, and as long as I don't hit any points twice vertically, it's a function. So I know that relations 3 and 4 are functions. 15. If we're going to write an equation and they give us the x's in order counting by ones, then we get to take a shortcut. Because we can literally just see the slope. I mean, you can do y minus y over, you can do all that work I taught you. It's still going to work. But if they give you a table and my x's are in order like this, I want you to take the shortcut. We're just adding 5 every time. So my slope has to be 5. My answer is already C or D, right? And the y-intercept, again, you can do all the algebra I taught you, or you can just look where your x is 0. The b is right in front of you. So the answer has to be, the equation is y equals 5x minus 2. So for 16, we're going to select the equation for the same thing. Same thing. They give us a graph. We need to know where it hits the y-axis and what the slope is. So I take a look and I see here, look, these are 2 points. This is a negative slope. I'm going down 3 to the right 1. So my slope is negative 3. Okay? And I see that the line hits the y-axis at 4. So my y-intercept is 4. Okay? So, but the trick here is that I switch the order on you because I want you to understand y equals mx plus b is the same as y equals b plus mx. The slope still goes in front of x, and the y-intercept is 4, so make sure if it's a negative slope, you have minus 3x there, okay? All right, don't let me trick you on that one. All right, so 17. 17, we have a graph right here. And for 17, you have to understand slope and y-intercept. It's purposefully kind of ambiguous there. You can't read the numbers real well. So let's start with the y-intercept. If you look at this, the line hits up here at positive, so I know my answer can't be letter B. And it's lower than halfway. So no, my answer can't be C, where the y-intercept is 3. That's more than, halfway up to 5 is 3 is more than halfway up to 5. So my answer, just by looking at the y-intercept, has to be A or D. Now, the way you do this problem without any work is, if it's like rise 1, run 1, or fall 1, run 1, if it's a slope of 1, it's always a 45 degrees, either positive or negative, right? So steeper is a greater absolute value of 1. Shallower is a fraction. So this is not very shallow, so it can't be D. So the answer, the only option is A, y equals negative x plus 1. So you have to understand slope and y-intercept for that one. There's no work to show. I hope once you understand that, you get that easily without any work in the future. So 18, we're looking at an equation. They say, why is it not linear? Well, you guys have to understand, linear means this, just regular x, regular y, right? We taught that in class. It means y to the first power x to the first. So you can't have anything weird around your x's or your y's, like absolute value bars, or cubed, or to the negative first power on the bottom of a fraction, okay? So if I look at my answers for 18, it says, now why is this not a function? Is it A? The coefficient has to be 1? No, coefficients don't matter. The numbers in front of x don't matter. They can be square root, squared, pi, it doesn't matter. What matters are y's and x's in order to be a line. B, the graph doesn't go through the origin. Well, you don't have to go through the origin to be a line. You have to go through the origin to be proportional, but not to just be a line. So the answer is not B. C, the exponent for x is not 1. Yep, the exponent squared, therefore it's not a line. And D, the constant has to be, nope, the numbers don't matter. It's all about x's and y's. So the answer can't be D. The only right choice is C. Know that answer. It's going to be the exact same on the test. Hint, hint. All right, so number 19. A relationship is proportional. All right, if they say that, I know it's y equals slope x. All I need is 1 point, right? So they give me a point. All I do is put y over x, and I simplify. There's my equation. Proportional means I get to write this. All I need is 1 point, put y over x, and I have my equation. Now, they say find y when x is negative 3. So I put negative 3 where x goes, and I simplify, and that's it. 2 times negative 3 is, the answer is negative 6. And for the last one, they tell us, number 20. A well already had some water. That means it's not proportional, right? We're going to have a y-intercept. And they say it started filling up. After 15 minutes, class, I told you guys, time is always what? Time is always x, right? Now, of course, you can write a math problem where it's not, but it doesn't really make sense in real life. So for 99% of your math problems, time is always x, money is always y. That's how I know the 15 goes here, not here. Okay, it says 15 minutes, the height of the water is 190 inches. The water is 310 inches after 25 minutes. Again, time is always x, so put the 25 first, not the 310 first. Now that we have a set of points, we know how to write the equation. But in the end, they tell us how high was the water when we started. In other words, they're asking us to find the y-intercept. So all I got to do is I got to find the slope first, subtract those, find the slope. Sorry about the bell there. Class is about to start. Find the slope, take 1 point. Take 1 point, plug it in, right? Put the y where the y goes, the x where the x goes. I'll pick this point, put the slope that I found right here, solve for b, and that's my answer. The answer is 10 inches. All right, 8th grade, I hope that helped you guys out.